Hello all. In this lecture we have discussed about the remaining user interface component. First one is graphics. Graphics controls allows application to draw onto the component or on image. Next one is graphics control and description. First one is graphics. It is the top level abstract class for all the graphics contents. Next one is graphics 2D. It is a subclass of graphics class and provide more sophisticated control over the geometry, coordinate transformation, color management, text layout. Third one is Arcs 2D. Arcs 2D is the abstract superclass for all the objects that store a 2D arc defined by a framing rectangle, start angle, angular extent, length of the arc, and a closure type, open, chord, or pi. Then next one is cubic curve 2D. The cubic curve 2D class is the abstract superclass for all the objects which store a 2D cubic curve segment, and it defines a cubic parametric curve segment in XY coordinate space. This is the graphic control and description. Next one user interface component is layout managers. The layout managers are used to arrange the components in a particular manner. The Java layout manager facilitates us to control the positioning and the size of the components in GUI form. Layout manager is an interface that is implemented by all the classes of layout manager. AWT provides the following layout managers: flow layout, grid layout, border layout, grid back layout, box layout, card layout, and others. Then first one is border layout. The border layout is used to arrange the components in the 5 regions, that is north, south, east, west, and center. Each region, that is area, may contain one component only. It is the default layout of a frame or window. The border layout provides the 5 constants for each region, that is public static final in north, public static final in south, public static final in east, public static final in west, public static final in center. These are the 5 constants that provided, or the 5 regions that are provided by the border layout. We need not place the component to all the 5 zones. The north and the south component may be stretched horizontally, the east and the west component may be stretched vertically, the center component may be stretched both horizontally and vertically to fill the any space left over. This is about the border layout. Then next one is the constructor of border layout class. First one is border layout. Create the border layout but with the no gaps between the component. And second one is a border layout in bracket int h gap int v gap, means it creates the border layout with the given horizontal and the vertical gaps between the component. This is the constructor used for the border layout class. Then next one is the example of border layout class. Import java.awt, import javax.swing, public class border, include jframe f border, creating the new frame f is equal to new jframe, creating the buttons, that is j button, b1 is equal to new button, include north, the button will be labeled as a north, j button b2, new button south, that is the button will be labeled as a south, j button b3, that is new button east, then the button is you will be labeled as a east, j button b4 is equal to new button, new j button west, the button will be labeled as a west, j button b5 is equal to new j button center, that is the button will be labeled as a center. Then add frame f.add b1 border layout north, that is b1 will be placed in the north direction, f.add b2 border layout south, that the b2 will be placed in the south direction, f.add b3 border layout east, that the b2 will be placed in the east direction, f.add b4 border layout west, that the b2 will be placed in the west direction. f.add b5 border layout center, that is b2 will be placed in the center. Then set the size, that is f.set size frame size 300, 300, f.set visible true, then public static void means string arcs, new button curly bracket complete. Then the output that represent the border layout with it create the frame with representing the 5 direction, that is east, west, center, north, and south. West on left, east on right, north on up, south on down, and center on middle. This is the output that represents the border layout. Then next one is grid layout. Next one is layout manager is grid layout. In the next one is manager layout manager is grid layout. The Java grid layout class is used to arrange the component in a rectangular grid. One component is displayed in each rectangle. In java.awt grid layout, the components are arranged in a grid, that is a matrix of rows and column inside the container. Components are labeled, the component added in a left to right, top to bottom manner in the order that they are added via method container.add a component. Constructor used for the grid layout class is, first one is grid layout null bracket, create a grid layout with one column per component in a row. Next one is grid layout in bracket int row int column, that is create a grid with layout with a given rows and column but no gap between the components. Third one is grid layout int rows int column int h gap int v gap, means create a grid layout with a given rows and columns along with a given horizontal and the vertical gap. This is the constructor used for the grid layout class. Then example that represent the grid layout is import statement, import java.awt, import javax.swing, public class grid layout. Example including the jframe frame obj, constructor grid layout. Example f obj is equal to new j frame, creating the 9 buttons, that is j button bt and 1 is equal to new j button 1, new j button 2, new j button 3, new j button 4, new j button 5, new j button 6, new j button 7, new j button 8 and new j button 9. Then adding the buttons to the frame, that is since we are using this parameter constructor, therefore the number of column is equal to the number of button we are adding to the frame, then the rows count remains 1. Frame obj dot add bt and 1, frame obj dot add bt and 2, frame dot add bt and 3, frame obj dot add bt and 4, frame obj dot add bt and 5, frame obj dot add bt and 6, frame obj dot add bt and 7, frame obj dot add bt and 9, 8, frame obj dot add bt and 9. Setting the grid layout using the parameter less constructor, that is a frame obj dot set layout new grid layout, frame obj dot set size 300, 300, frame obj dot set visible true, main method public static void main string args vs new grid layout. Example curly bracket complete. Then the output that represent the grid layout is, it divide the frame into the 9 buttons, that is 1 2 3 4 5 6 7 8 9. This is the output that is used to represent the grid layout. Next one, layout manager is flow layout. In the java.awt flow layout, components are arranged from left to right inside the container in the order that they are added via method of container.add in bracket a component. When one row is filled, a new row will be started. The actual appearance depends on the width of the display window. The Java flow layout class is used to arrange the component in a line one after another in a flow. It is a default layout of the applet or panel. The fields for the flow layout class is public static final int left, public static final int right, public static final int center, public static final int leading, public static final int trailing. The next one is the constructor used for the flow layout. First one is flow layout null bracket. It creates the flow layout with a center alignment and a default 5-unit horizontal and vertical gap. Flow layout int aligns create a flow layout with a given alignment and a default 5-unit horizontal and the vertical gap. Flow layout int align int h gap int v gap create a flow layout with the given alignment and the given horizontal and the vertical gap. These are the constructor used for the flow layout. Next one is the example for flow layout is import statement, import java.awt, import javax.swing, public class flow layout. Example jframe frame obj, constructor flow layout. Example creating a frame object, that is frame object is equal to new jframe, creating the button, that is j button b1 is equal to new j button 1, j button b2 new j button 2, j button b3 is equal to new j button 3, j button b4 is equal to new j button 4, j button b5 is equal to new j button 5, j button b6 is equal to new j button 6, j button b7 is equal to new j button 7, j button b8 is equal to new j button 8, j button b9 is equal to new j button 9, j button b10 is equal to new j button 10. Then adding the button to the frame, that is a frame obj dot add b1, frame obj dot add b2, frame obj dot add b3 b3 frame ops dot add b4 frame ops dot add b5 frame ops dot add b6 frame ops dot add b7 frame ops dot add b8 frame ops dot add b8 frame ops dot add b9 frame ops dot add b10. Then the parameter list constructor used, therefore the alignment is center horizontal as well as the vertical graph is unit of 5 unit. Frame ops dot set layout new flow layout frame ops set size 300 300 frame ops dot set visible true. Then main method public static void main string args vs. Then new flow layout example curly bracket complete. This is the example to represent the flow layout. Then the output for the flow layout, it represents the 10 button, that is 1 2 3 4 5 6 7 8 9 10, a frame consisting the 10 button. This is the example of, and the one button is after the one another, as a 1 after 2 2 after 3 3 after 4. This is the output that represents the flow layout manager. Then next one is card layout. The Java card layout class manages the component in such a manner that only one component is visible at a time. It treats each component as a card, that is why it is known as a card layout. Then the constructor used for the card layout class is, first one is card layout, null bracket, create a card layout with a 0 horizontal and the vertical graph. Next one is the card layout int h gap int y gap, that's create a card with the horizontal given horizontal and the vertical gap. Next one is a commonly used method for card layout class. The first one is a public void next container parent. It is used to flip the next card of the given container. Public void previous container parent, it is used to flip the previous card of the given container. Next one is a public void first container parameter. It is used to flip the first card of a given container. Public void last container parent, that is it is used to flip the last card of the given container. Public void show container parent string name, that is used to flip the specified card with the given name. These are the commonly used method for a card layout class. Then next one is the example that represents the card layout class. Import statement, that is the import java.awt, import java_x.swing, import java.awt.event. Public class card layout example extend the JFrame, implement the action listener including the card layout CRD, button variables to hold the reference of the button, that is J button btn1 btn2 btn3 container cpen construct of the class card layout of example. Cpen is equal to get content pane. Default constructor are used, therefore the component will be cover the whole area. CRD is equal to new card layout, cpen.set layout CRD, creating the button, that is btn1 is equal to new button apple, btn2 is equal to new j button boy, btn3 is equal to new j button cat, adding the listener to it, that is btn1 dot add action listener this, btn2 dot add action listener this, btn3 dot add action listener this. Jpen add dot add a btn1 first card is the button btn1, cpen dot add b btn2, that is the first card is the button btn2, g cpen dot add c but btn3, that is the first card is the button btn3. Public void action perform action event E. Upon clicking the button, the next card of the container is shown after the last card. Again, the first card of the container it will shown upon the clicking. CRD.next in bracket cpen main method public static void main string args vs creating the object of the card class card layout example first card layout example first CRD1 is equal to new card layout example first size is 300 by 300 CRDL card layout dot set size 300 300 CRDL dot set visible true, CRDL dot set default close operation exist underscore on underscore close curly bracket complete. This is the example that represents the card layout. Then the output that shows for the card layout is first we are representing the A1 button, that is apple, then clicking on the that button we are representing the next button, that is when the button name is apple is clicked, then we get the second button name, that is a boy. Then next one is when the boy button is clicked, then we get a third button name, that is a cat, and again we reach the first card of container if the cat button is clicked and the cycle is continuous, one after one another button is click or shown. This is the output that represents the card layout. This is all about the user interface component layout manager. Thank you.